So, in the previous segment, we saw how to create a first OpenGL triangle. Well, now as you know how to create the first OpenGL triangle, let's move a little bit further and let's draw our first rectangle using OpenGL. Well, you might ask that what's the big deal about that? We'll just set the primitive to GL rectangles and boom, a rectangle is drawn. The thing is that in OpenGL, the primitives that are available to us are only a point, a line, and a triangle. So, to draw any shape other than these three, we have to use the combination of these primitives. Usually, we use the combination of triangles. For example, when we want to draw a rectangle, we'll draw two triangles. As you might imagine, two right angled triangles. Okay? So, let's see how we can draw these two triangles and create a rectangle. Well, there are three ways in which we can do the same thing. We'll see each method, what are its advantages and what are its disadvantages, and what is the best possible method for you. Okay? So, the basic idea is to draw two triangles. So, the first approach or the first method basically involves increasing the vertices we supply to the vertex data. So initially we were supplying 3 vertices for the first triangle. Now we'll supply 6 vertices for the two triangles. Okay? So you can imagine the vertices for your own, not a big deal. So these will be the vertices of the second triangle. Okay? Now, the only change you have to do to render instead of 3 vertices, 6 vertices is inside the function of glDrawArrays, where we specify to draw only 3 vertices, and we'll change this value to 6. So let's try running our small program. Ta-da! We got ourselves a rectangle in OpenGL. So that was the first method of basically increasing the number of vertices for the second triangle. Well, though this method is simple and very effective actually, but what happens is when the complexity of the object increases, as you might imagine, the number of triangles you have to draw also increases. So just imagine that for each triangle you use, you have to specify 3 more vertices. Not only these vertices, but as we'll see in the later tutorials, some other vertex data may be associated with this vertices. So also this whole lot of vertices have to pass on through the graphics pipeline, and that hinders performance heavily. So due to these problems, we move on to the second method we can use. This method is called the indexed rendering. So in this method, what we do is instead of using 6 vertices, we create only the unique vertices. So we know in a rectangle we only need 4 vertices. So we'll write the unique vertices. Now after this we create another array of this unsigned int type. Remember this data type is important here, and name it indices. So we use this data type unsigned int here because we know that unsigned int starts from a particular point, that is 0, unlike the integer type. So when you're using this indexed rendering method, the vertices we created, for example these inside the vertex data, these are indexed starting from 0, then 1, then 2, and then 3. Now what we do inside this indices array is specify the combination of indices of the vertex data to draw the two triangles. For example, to draw our first triangle, the indices we need is 0, 1 and 2. Now to draw the second triangle, we need the vertices 0, 2 and 3. Is it okay? So instead of writing all the 6 vertices, we just wrote 4 unique vertices and indexed them using the indices array. Now, see, this indices array do not pass through the graphics pipeline, so we would have to buffer it at the start of the program, like we did for the vertex data. So, to use this indices array, what we do is, instead of using this function of glDrawArrays, we use the function of glDrawElements. Now, this glDrawElements contains 4 arguments. The first one is the basic primitive type. So, because we want it to be a combination of triangles, we'll use glTriangles. Second one is how many indices are there inside the index array. So we know there are 6 indices. Third one is what is the data type of this indices array. So I mentioned before that it was of the type unsigned int. And the fourth one is the indices themselves. So after running this program, let's see what happens. Ta-da! We again got the same rectangle. But instead this time we only mentioned the indices and mentioned the unique vertices that are present. So basically this method does not seem too long and it helps in the performance of the program also. So why do we need the third method? So see, this method also contains some disadvantages. So although the indices array is not passing through the graphics pipeline, but see, we are passing on the indices array inside the glDrawElements function. This function is basically rendered every frame. So we have to pass this indices array every frame. Now, what is the big deal in that is this indices array currently is stored inside the CPU and all the rendering happens inside the GPU. So what that means is for each frame we have to pass on this indices array from the CPU to the GPU, and that is very performance costly. So tackle this problem, we use a third method called indexed rendering using an ElementBuffer object. So inside the third method, what we do is just like a vertex buffer object, we create another buffer object called an ElementBuffer object and pass on our indices to this ElementBuffer before start of our render loop. So in this way we only have to pass this indices once from the CPU to the GPU. That helps in performance heavily. So the second step usually is initializing this buffer. Third step is binding this buffer. So the type of buffer we have to bind it is called an element array buffer, and an EBO. And let's send our indices inside this buffer. Element array buffer, size of indices, gl static draw. Okay, so also remember one thing, that now our vertex array object here contains a vertex buffer object, an element buffer object, and the vertex attribute pointers. So basically the element buffer object is also contained inside the same VAO. Remember this thing. So for this good practice, we'll unbind our element array buffer also. Just a good practice. So after creating this element buffer object, the only thing we need to change here is, so while we used to send our indices inside the render loop, we'll just write here 0. This will tell OpenGL that the indices are already present in the GPU. Okay, so let's try running this program. Ta-da! We again got our same rectangle. Well, so these were the 3 methods in which you can draw complex objects using OpenGL. Well, before moving on to the next topic, let me show you a cool thing that you can do while rendering using this indexed buffer. So I'll use the function GL polygon mode. Here I'll write GL front and back and the mode as GL line. So let's see what happened to our rectangle. Ta-da! Now the rectangle is drawn in the wireframe mode. That means that only the edges of the triangles are shown here. Also, you can see that the rectangle is indeed constructed using two triangles. This one was our first triangle and this one was our second triangle. Okay? So basically, inside this function of GL polygon mode, the first argument can be a GL front, GL back, or GL front and back. This makes more sense in 3D when we actually have back and front shapes, but for 2D you can just write GL front and back. And the second argument can take the form of line or fill, that is GL fill. So if I have specified it as the GL fill, that is the default value, then our regular rectangle will be drawn. Okay. So I want to clarify one thing that some of you might be thinking that why we need this fancy function while we can just change the primitive to a GL line. So let's see, does the effect remain same or do we get a different output? So here we'll write the primitive of line, that is GL line strip. So let's see what happens to the output. Ooh, well, what happened here? One of the edge of the rectangle is missing. Well, let's analyze what happened here. Now see, what happened here was when we were mentioning the primitive as the GL triangles, OpenGL took 3 indices at a time. So these 3 indices were taken for the first triangle and these 3 indices were taken for the second triangle. However, when I mentioned the primitive as a GL line strip, so what OpenGL did is it took 2 indices at a time because only 2 are needed to construct a line. So it took 0 1 first, then 2 0 and then 2 3. So that's why we get a slightly different output that is different from the wireframe mode. So is this difference clear? Okay. Now one thing that I forgot to mention in the previous segment is, we created all these OpenGL objects like VAO, VBO, EBO, or shader program, Vertex shader and fragment shader. So at the end of the program, it is a good practice to delete these OpenGL objects because they use a chunk of memory. So we'll use the functions like gl delete buffers. Is it okay? So if you have been following our tutorials till now, then you have learned how OpenGL basically works in the code. Okay? Now, before ending this tutorial, I want to revisit some of the concepts I left behind in our Hello Window tutorial because I thought you were not ready for that. Well, the first thing I want to retouch is our old friend viewport. So, I explained to you how this viewport works using a drawing. But let me show you that whatever I told you was not a lie about it. And so if you remember, then we created a 600 by 400 viewport in that drawing. So let's see what's the difference happens if I put the viewport as 600 by 400. You see, if you didn't notice the difference, let me change this to this. See, so in the previous one, the viewport decreased, therefore the rectangle was confined in a 600 by 400 area only. However, you might have noticed that although the viewport was only 600 by 400, but all the 800 by 600 space was colored using this greenish background. So this concept of viewport only applies to the object that we draw using the graphics pipeline. Okay. Now, you know, talking more about this window or hello window, you know, there are some buttons here. As you can see, there's a minimize button, there's a full screen button, and there's a close button. Also, you might know that in Windows we can actually resize our window as we want by moving on to one edge and dragging that edge if we want. So let's try doing this. Well. I hope that our rectangle still was in the center, but it doesn't seem so. So why is that happening? Some of you might have guessed because although the size of the window is changing, but our viewport here is constant and still is 800 by 600. So I don't like that, frankly. I want that my rectangle is always at the center of the screen, no matter how I resize it or if I go full screen. It's not in the center, you see? So one way we can do this is basically changing the viewport each time the window is changed. So I can cut a little function here and write it inside the render loop. Now what I'll do is I'll took two variables, namely width and height, and write it here width and height. So now the only thing that is needed to be done is basically retrieving the current width and height of our window. So what do you think? How can we do that? Well, luckily glFw provides us with a similar function that is called glFw get framebuffer size. Inside this function it takes three arguments. The first one is window, then the variable width to store the current width, and the variable height to store the current height. So I think that should do it. Let's see if it works. Ah yes, I like that. Our rectangle is again in the center of the screen and I appreciate it. Okay. So while achieving this, you might see that inside this function it says something called as a frame buffer. So let me introduce you to this entity called the frame buffer. Well, do you remember this? While using this GL clear, I mentioned that we can actually clear three buffers, but that is the color buffer, the depth buffer, and the stencil buffer. Well, basically, the combination of all these buffers is called the frame buffer. Is it okay? Also, the thing we use, that is a frame buffer size, that is the size of the window, is also contained inside this frame buffer along with this color buffer, depth buffer, and stencil buffer. So is it okay? Now this effect that we achieved using this glFw get frame buffer size and the GL viewport can be also achieved using something called as a callback function. So what is this callback function? So you see, we basically gets the frame buffer size and pass it on to the GL viewport for every single frame, even if we are not resizing our window. Well, not much, but it hinders the performance in some way. So what we can do is we only call this GL viewport function to change the current viewport when our window is changed or our frame buffer size is changed. So how do we achieve that? Well, we achieve this using the same callback functions. So basically, what this callback function do is it basically gets called back whenever some event is triggered. So, for example, to create a frame buffer size callback, what we do is we actually have to create a function in C++ with this type. Let's call it frame buffer size callback. Now, one particular thing about this callback functions is it have a very particular syntax. So I'll leave a link in the description about this article on the GLFW where you can learn about all these callback functions. For example, like the frame buffer size callback, there exists an input callback or a mouse callback and all sorts of callbacks. You can read there about these callbacks in detail. So about this frame buffer size callback, the syntax of it is first argument is the window, then width, and then height. And inside this function, we use GL viewport 0 width and height. So this is the syntax of a frame buffer size callback function. So actually I have to learn this function. What is the syntax? Well, now currently it is just a function in C++. Also I have to mention that we have to use it as a callback function. So here we'll use the glfw function called glfw set frame buffer size callback, the window, and our frame buffer size callback function. So let's just delete this. And let's try running our program again. So, ta-da! Yes, I got my rectangle back in the center. So that's how callback function works. So I hope you have learned about the callback functions in the glfw library. I hope you'll read about the documentation about other callback functions because then only you will achieve the most control over glfw and any windowing library. Okay. So another thing that I want to go back to is, do you remember that when we created our first window, that is from the glfw create window, I left the fourth and fifth parameter as null. So I told you that I'll tell what this null stands for. So let's see what does null does and can we replace it with something else. Well, if you can see here in the description, it says the fourth argument is the glfw monitor object. So just like the glfw window object, you can actually create a glfw monitor object and you can store any number of monitors that are connected to your device currently into that glfw monitor object. So I'll create a monitor object. Let's name it as A. Now to get our primary monitor, that is your current monitor or your main monitor, so we use this function glfw get primary monitor. Okay, so now all of your configuration of your current monitor is stored inside this object A. So what will happen if I replace this null with our A? Let's see. So let's try running the program. So that's how you get a full screen window in glfw. Okay, so just like this small thing about the glfw monitor, there are various type of things like for the fifth argument, it gives the option to share your monitors across various monitors. So these things are related to the glFW more, and I won't cover these things in our OpenGL tutorial. But if you want to deeply understand about these things, I'll again leave a description to a link where you can find all the options about your monitor or your window in glFW. So finally, that's it for the tutorial part. Well, see, in this tutorial, in these three segments, we covered a lot of information, and one can only apply this so much information if he or she practices them on a regular basis. So, as you can see here, they have provided three exercises along with their solution. I'll give the link to this page in the description, not to worry about. So try these problems, and I hope they will clear your concepts about various things we learned. That was the VAOs, the VBOs, EBOs, shaders, shader programs. Okay, so that's it for today. If you like the video, press the like button and subscribe for more such tutorials. Thank you.